So today we're going to learn two new derivatives. So we're going to talk about the natural exponential, which is e, right? E is just a mathematical constant, kind of like pi, right? It's known as Euler's number. And there's a lot of special things about e. Ln of e is just 1, but there's a lot more applications with it, a lot of in physics and even in finance. But e is basically a special number, and just like how pi is 3.14, e is around 2.7 or 2.718. So that's e. And then also logarithmic functions, and specifically we're going to be discussing ln, right? The natural logarithm, so like ln of x. And one thing to just kind of remember just before our notes is we do need to know that the ln of 1 is equal to 0, and the ln of e, those kind of cancel out, and so we get 1. Also, the ln of 0 or even any negative is undefined. So those are just some things to know going into this. So our rule for the natural exponential for e to the x. So if we're going to take the derivative of e to the x, and we're going to write this in a little bit of a new notation, but this means the derivative with respect to x of e to the x, and this is probably the easiest derivative we're ever going to have, is just e to the x. It's itself. Now, if we wanted to do chain rule, the derivative of e to anything else, so of e to a box, would be, so the same process. What was the derivative of e to the x? Was e to the x. So it's e to the box, but then times the derivative of that box. So those are kind of two rules for differentiating e to the x. So just a little bit of practice. If we were going to do the derivative of e to the sine x, right? Sine x would be our box. So it would be e to the sine x. And times, right, if I get rid of the e, the derivative of sine x is cosine of x. Okay, if you want to pause this video and try the next few on your own, you can. Feel free to pause it and then try a few of these. And these are very easy derivatives, so it shouldn't be too bad. So second one, same process. E to the 2x plus 3 would be e to the 2x plus 3, and times the derivative is 2. Really, I guess I should put that in parentheses. And we can move the 2 as a coefficient to the front and write this as 2 e to the 2x plus 3. Okay, what if we already have a coefficient in front? It just hangs out in front. So it's 3 times. We don't need to do product rule because there's not a second x. It's just 3 times what would be the derivative of e to the 2x would be e to the 2x times 2. Now we can multiply our coefficients and get 6 e to the 2x. Now in our next one, we do have an extra x. So when we have two x's that are next to each other, right, and these two terms are next to each other, they're being multiplied, we do product rule. So this would be product rule. So product rule says take the derivative first. So the derivative of 2x plus 3 is 2. Leave our second product alone. Then add on, leave the first one alone, and take the derivative of the second one. Now the derivative of e to the 3x will be e to the 3x times 3, or 3e to the 3x. So this gives us 2e to the 3x plus 2x plus 3 times 3e to the 3x, and we'll distribute this. So we get 2e to the 3x plus 2x, 6x, 2 times 3 is 6, plus 6x, e to the 3x, plus 3 times 3 is 9, e to the 3x. And so we can add like terms. Our like terms are going to be anything that have the same e to the 3x or x e to the 3x portion, right? So x e to the 3x is going to be alone, but 2e to the 3x and 9e to the 3x both share that e to the 3x, so they're like terms. So this will be 6x e to the 3x plus 11 e to the 3x. Okay. Next one, again, will be a product rule, and we know it's a product rule because we see two x's next to each other being multiplied. So f prime of x, derivative of x squared is 2x. We leave our e to the 2x second part alone. Then plus, now we leave the first part alone. And the derivative of e to the 2x is e to the 2x times 2. And when you get good at these, you don't have to write it the way I did. You can just immediately jump to 2 e to the 2x. So when we expand 2x e to the 2x plus, this is x squared times 2 e to the 2x, which is 2x e to the 2x plus 2x squared e to the 2x. And that's a great answer. Sometimes you'll see these factored. So sometimes they'll say, hey, what can we factor out? We can factor out a 2x e to the 2x. You get like 1 plus x. You might see that. Right, in the previous one we could have factored as well. We could have factored out an e to the 3x. So just be aware that that might happen. But for your answers, I don't need you to worry about factoring them. Okay, this next problem is a double chain rule. And we see the very outside is the square root. So first I'm going to just isolate this as a square root. What's the derivative of a square root? 1 over 2 square root of that box. So e to the 2x minus 6. Now I'm going to kind of cancel out my square root. And next I have e to the 2x minus 6. What's the derivative of e to the 2x minus 6? Well, now that's going to get boxed. So times e to the 2x minus 6. Let me put this in parentheses. Times the derivative of the box is 2. So we can take all of this to the numerator and write this as, move the 2 to the front, 2 e to the 2x minus 6 divided by 2 square root of e to the 2x minus 6. The 2's cancel, and we get e to the 2x minus 6 divided by the square root of e to the 2x minus 6. And that's a perfect answer. Okay, there actually is, we can simplify this more. And, it's something where we could end up simplifying it a little bit more, but I'm okay with that as your answer. If you wanted to simplify it a little bit more, you could, rationalize it times square root of e to the 2x minus 6 times square root of e to the 2x minus 6, and you'll get it to cancel out a little bit more, but I'm okay with this. Okay, our next one is a quotient, right? So we have a quotient, so low d high minus high d low, all over low squared. So low is 3x squared. High will be e to the 5x times 5 minus high e to the 5x. D low will be 6x. All over 3x squared all squared. So when we multiply 5 times 3 gives 15x squared e to the 5x minus 6x e to the 5x. All divided by, now when we square this, make sure we square both the 3 and the x squared. So divided by 9x to the 4th power. And we notice that we can divide every term by 3. So this will be 5. This will turn to 2, and this will turn to 3. And we can also divide out everywhere by 1x. So we can take out an x, make this x to the first, and make this x cubed. And so that gives us 5x e to the 5x minus 2 e to the 5x divided by 3x cubed. And this is a perfectly fine answer. Sometimes, like if it's multiple choice, you might see the e to the 5x part factored out, right, and have it written as 5x minus 2 over 3x cubed. The key, kind of on your homework, just look at my answer key and keep simplifying until you get to what I have. And on multiple choice, basically simplify until you get to one of the answers. And then on free response, once you've simplified a little bit, you're good. On free response, honestly, you could have even left the answer like that, and it'll be marked correct before I'd canceled anything out. So there's e to the x. Now we're going to move on and do natural log, which is kind of e to the x's friend. So the derivative of ln of x, again, these are just derivatives that we're going to memorize. Just like how we memorized the derivative sine was cosine, we're going to memorize these two derivatives. So the derivative of ln of x is 1 over x. And so similarly, the derivative of ln of some box of anything besides x, this is the chain rule portion of it, will be 1 over the box times the derivative of the box. And a lot of times this portion will get moved to the top, to the numerator, but we're going to write it like that. So the derivative of ln of 2x minus 3, right, we'll write f prime of x equals, so the derivative of ln of x was 1 over x, so we're going to write 1 over 2x minus 3, and then times its derivative is 2. We move the 2 up to the numerator and write this as 2 over 2x minus 3. Okay, and again, if you want to pause the video, try these next few on your own, you can. And then just come back and check your answers, or you can just watch and take notes with me. So, right, there's our box. So the derivative ln of box is 1 over 3x squared plus 2x. Now times, this is very important. You need this parentheses. If you don't write this parentheses, you're putting yourself in a spot where you can lose points on the AP exam. So this is 6x plus 2 divided by 3x squared plus 2x. And do not try to cancel anything out. You cannot cancel out the 6 and the 3 because there's not a 3 term everywhere. You can't cancel out any x's, there's not an x term everywhere. You can't cancel out the 2's because 3 is not divisible by 2. It has to cancel out everywhere. So I see a lot of people make mistakes on this kind of a problem, like they'll cancel out the 2's. You can't do that. This is fully simplified. You cannot cancel out anything on this question. Okay, next one, ln of cosine x. So our box is the cosine x. So f prime of x will be 1 over cosine x times the derivative of cosine is negative sine of x. This gives us negative sine of x divided by cosine of x. And anytime you see sine x over cosine x, a lot of times on the AP exam, they're going to just switch that, change that to tangent of x. So we get negative tangent of x. All right, and our next one will have kind of a double chain. So this is ln of the entire, the box will be with the square root around it. Right, we always, with chain rule, we always start on what's the very outside function. The very outside function or thing happening is the ln. So we're going to write this as f prime of x equals 1 over square root. It's not 1 over 2 square root because we're doing ln. What's the derivative of ln is just 1 over that box. So 1 over square root of 2x minus 4. Then times, so I'm going to cancel out the ln. Now we're looking at the radical. What's the square root of a radical? So now our box is the 2x minus 4. The square root of a radical is 1 over. This is where we have the 2 square root of 2x minus 4. And finally, times its derivative, the derivative of 2x minus 4 is 2. So what this does is this gives us, we're going to move the 2 to the numerator. If you wanted to cancel them out here, you could cancel them out there. But I'm going to save that for later. So I'm going to move the 2 up to the numerator. The denominator is 2. Now, when I do square root of 2x minus 4 times square root of 2x minus 4, it turns to 2x minus 4 in a parentheses. So you can get rid of those 2's. Simplify those, put a 1 in its place, and we get 1 over 2x minus 4. Okay? So that's all for this lesson, and I'll see you guys in class.